Alright, how you guys doing today? This is Mr. Muscarella coming at you, and we're going to take a look at example 1C for determining the convergence or divergence of a series using the integral test. Now, in this example, one of the things you want to recognize is that the terms are all positive. So that's the first thing you want to recognize, is that all the terms are positive. There's no alternating signs. The second thing, the numerators in all of them are 1, but the denominators start with 3, and then they go up to 5, and then they go up to 7, and 9, and 11, and so on and so forth. So it's increasing by 2 every single time. So this particular formula for this series, you got to recognize that that is just going to be this piece right here. 1 over 2n plus 1 as you go from 1 to infinity. So it's 2n plus 1, because remember, if you plug 1 in for n, you want the denominator in the first term to be 3. So that's why you have to use 2n plus 1 for our formula here. Now once we've got our formula set up to use the integral test, remember we've got to go through and kind of prove 3 things. The first thing we want to do before we start proving everything is rewrite this as a function. So we're going to let f of x be 1 over 2x plus 1. We're just replacing the n with the letter x. So the first thing in the integral test that you always want to check is f positive? And I'm just going to write positive with a little plus sign right there. So 1 over 2x plus 1, if we're starting with 1 for x and increasing, this is always going to be positive. So that's going to definitely check out. Now the second thing that you want to check is the continuity. So is this function continuous? Well, it's continuous everywhere. I'm just going to abbreviate that CONT, except at one particular value. And that one particular value is x equals -1/2. So you can't have x equal to -1/2. Otherwise, our function is continuous. Now the decreasing piece, so that's a third thing we've got to check, is to see if the function is decreasing for all x's greater than or equal to 1. So when we take a look at that, what we're going to do, of course, to figure that out, we have to look at the derivative. So when you take a look at the derivative, we've got f prime of x equals -2 over 2x plus 1, that quantity squared. Now where I want you to take a look is at this value right here, this -2. Of course, that's always going to be negative. And in the denominator, you've got 2x plus 1, that quantity squared. The denominator, that's always going to be positive. So if you have a negative over a positive, that means that your derivative is always going to be negative, which implies that the function is decreasing. So we've met all 3 criteria to use the integral test. So now we just have to do some math. So once we've determined that the integral test applies, because remember you got to prove the hypothesis for that, we're going to go ahead and start messing around with this guy. So the first thing that you do is we're going to take our function, write that from 1 to infinity, and then we're going to replace b as we use the limit process. So b is going to replace infinity, and we're going to have limit as b goes to infinity from 1 to b of 1 over 2x plus 1 dx. Now again, with the technical writing stuff, make sure you always include the dx. Don't just drop that off. Make sure your math writing is splendid. Now we're going to have to use a u sub here. So u sub, of course, is going to be our denominator, 2x plus 1, which means du is simply 2 dx. Now again, with your math writing, because I've noticed this a lot of times, students will just kind of drop that dx. Make sure you keep that in there because you need it. Now solving for du, or I'm sorry, solving for dx, of course, you get 1/2 du is dx. So when we make this u substitution, we're going to end up with this limit right here. So let me just kind of scoot this up a little bit so we can kind of see that. So we're going to end up with this, so here's our function is now turned into this using our u substitution. Now once we, you can kind of take the 1/2, and we're going to back substitute back in. So you want to recognize that when you integrate that, of course, you're going to have natural log of 2x plus 1, and then the 1/2. So we're going to evaluate the limit from 1 to b, or b to 1, whichever way you kind of take a look at that. So again, when we plug in b, we're going to have the expression, the limit as b goes to infinity of 1/2 natural log 2b plus 1, and then minus half natural log of 2 times 1 plus 1. And of course, you can do the 2 times 1 plus 1. You can probably do that mentally, which means most people would kind of go right to this step. So the limit of this first piece right here, like all of that blop right there, as b goes to infinity, natural log of infinity, well, that's just going to be infinity. That's huge. And then, of course, you've got natural log half of natural log 3, so you're going to be subtracting that. And any time that you have infinity minus another number, of course, that's just going to give you infinity. If you determine that the answer is infinity, then that means that the series from n equals 1 to infinity of 1 over 2n plus 1 is going to diverge by the integral test, because we didn't get a number, we got infinity, and infinity is not a number, so therefore this diverges by the integral test. All right, that's it for example 1c. Thanks for watching. Peace out.